Boolean type in Go. Question: what is the Boolean type in Go, and what is its zero value? Answer: in Go, the Boolean type is called bool. It can have only two values, true or false. The zero value of a bool is false. You can declare a bool without setting a value, and it will be false by default. You can also set it directly to true or false when you declare it. Question: how is the bool type stored in memory in Go, and what operations are allowed on it? Answer: in Go, the bool type uses 1 byte of memory, which is 8 bits, not 1 bit. The zero value is false. Internally, false is stored as 0x00, and true is stored as 0x01. A bool value can be compared with another bool using equal or not equal, but you cannot use less than or greater than operators with bool values. Why 1 byte, not 1 bit? CPUs are byte-addressable. The smallest addressable unit is 1 byte. Go cannot address a single bit. If you need bit-level packing, use a uint8 or uint64 with bitwise operations or a bitset library. Question: what are comparison operators in Go, and what do they return? Answer: comparison operators in Go are used to compare two values. They return a Boolean value, which is either true or false. Question: what are logical operators in Go, and what does short circuit mean? Answer: logical operators in Go are used to combine or change Boolean values. Logical AND returns true only if both sides are true. Logical OR returns true if at least one side is true. Logical NOT changes true to false and false to true. Short circuit means the second part of an expression is not checked if the result is already known. For example, in false and side effect, the right side is not executed because the left side is already false. In true or side effect, the right side is not executed because the left side is already true.
Question: what does operator precedence mean in Go logical expressions? Answer: operator precedence means some operators are evaluated before others. In Go, the logical AND operator has higher precedence than the logical OR operator. Question: why does Go not allow using numbers or empty strings directly in if statements like some other programming languages do? Answer: Go does not have Truthy or Falsy values. This means you cannot use numbers, strings, pointers, or NULL directly as true or false in if statements. For example, writing if 0 or if NULL will cause a compile error. Instead, you must always make explicit comparisons. Question: in Go, can you cast a bool value directly to an int or an int directly to a bool? Answer: no. Go does not allow direct casting between bool and int. If you try to convert a bool to int using int of b or an int to bool using bool of I, the code will not compile. Go does this to keep the language safe and clear. To convert manually, you must use logic. Question: why does the order of bool fields in a Go struct matter, and how can it affect memory usage? Answer: in Go, struct fields are aligned in memory, and bool values are very small, only 1 byte. If you place a bool before a large field like int64, Go adds padding bytes to keep alignment. This padding wastes memory. You should group bools and other small fields together, usually at the end of the struct. You can also use the field alignment tool to find and fix bad field ordering automatically. Question: what is the correct way to print Boolean values in Go, and which format verb should you use? Answer: in Go, you can print Boolean values using the fmt package. The simplest way is fmt.println b. which prints true or false. When using fmt.printf, the best and correct format verb for Booleans is %t. It is made specifically for bool values and always prints true or false. You could also use %v, which works for many types and prints the value.
Question: how do you parse and format Boolean values from and to strings in Go? In Go, you can use the stdconv package to work with Boolean strings. To convert a string to a bool, use stdconv.parseBool. It accepts values like true, false, 1, 0, t, and f in any case. For example, the string 1 becomes true and the string 0 becomes false. If the string is not a valid Boolean value, like yes, parseBool returns an error. To convert a bool back to a string, use stdconv.formatBool, which returns the string true or false. Question: how are Boolean values handled when encoding and decoding JSON in Go? Answer: in Go, Boolean values in JSON are handled by the Encoding JSON package. When you marshal a struct to JSON, a bool field becomes true or false in lowercase. If a bool field is false and has the omit_empty tag, it is left out of the JSON output. When you unmarshal JSON into a struct, missing Boolean fields are set to false by default. JSON only accepts lowercase true and false. Question: how can you represent an optional Boolean field in Go JSON, where you need to know if the value was missing or explicitly set? Answer: in Go, you can use a pointer to bool for JSON fields to represent an optional value. When the field type is *bool, it can have 3 states. Nil means the field was not present in the JSON. True means it was explicitly set to true. False means it was explicitly set to false. For example, if the JSON is empty, the pointer stays nil. If the JSON contains enabled equals false, the pointer is not nil and its value is false. This pattern is often called a 3-state bool and is useful when missing and false have different meanings. Question: when should you use atomic bool in Go, and what problem does it solve? Answer: in Go, you use atomic bool when a Boolean value is shared between multiple goroutines and can be read or changed at the same time. A normal bool is not safe for concurrent access and can cause data races. The atomic bool type, available since Go 1.19, lets you safely store, load, swap, and compare Boolean values without using a mutex. It is useful for flags like stop signals, enabled switches, or feature toggles in concurrent programs.
Question: why would you create a custom Boolean type in Go, and what is the main thing to be careful about? In Go, you can create a custom Boolean type when you want clearer meaning or custom behavior. For example, a type like enabled makes the code easier to read than using plain bool everywhere. You can also add methods to it, such as a string method that prints enabled or disabled instead of true or false. The important thing to remember is that a custom bool type is not the same as the built-in bool. You cannot assign a bool directly to it. You must convert it explicitly. This rule helps Go keep types safe and prevents accidental mistakes. Question: how can you work with Boolean values stored in interfaces or accessed using reflection in Go? Answer: in Go, when a Boolean value is stored in an interface, you must extract it safely. You can use a type assertion to check if the value is a bool and then read it. A type switch is another option when the interface may hold different types, including bool. When using reflection, you can check that a value is of kind bool and then read its value using the bool method. These steps are needed because interfaces and reflection hide the concrete type, so Go requires explicit checks
before using the Boolean value. Question: how do you toggle a Boolean value in Go in the simplest way? Answer: in Go, you can toggle a Boolean value using the not operator. If flag was true, it becomes false. If it was false, it becomes true. This is the simplest and most common way to flip a Boolean value in Go. Question: how do you do conditional assignment in Go since there is no ternary operator? Answer: Go does not have a ternary operator like condition question A:B. Instead, you use an if-else statement to assign the value. This is the most common and clear way in Go. You first declare the variable, then assign it inside if and else blocks. Another option is to write a small helper function that takes a condition and two values and returns one of them. Question: how can you check if all Boolean values are true or if any Boolean value is true in Go? In Go, there are no built-in all or any functions for Booleans, so you usually write small helper functions. To check if all values are true, you loop over the Booleans and return false as soon as you find a false value. If the loop finishes, all values are true. To check if any value is true, you loop and return true as soon as you find a true value. If the loop finishes without finding one, all values are false. This pattern is simple, fast, and commonly used in Go code. Question: why is using a normal bool unsafe between Goroutines, and how do you fix this problem in Go? Answer: using a normal bool between Goroutines is unsafe because reading and writing it at the same time causes a data race. One Goroutine may change the value while another Goroutine is reading it, which can lead to unpredictable behavior. Go does not automatically protect simple variables like bool from concurrent access. To fix this, you should use atomic bool from the sync-atomic package. Atomic bool lets you safely store and load Boolean values across Goroutines without a data race. Question: when should you use bit manipulation instead of many Boolean fields in Go? Answer: you should use bit manipulation when you have many related Boolean flags and want to store them efficiently. Instead of using many separate bool fields, you can pack them into a single number using bits. Each bit represents one flag, like read, write, or execute permissions. This saves memory and makes it easy to set, clear, toggle, and check flags with simple operations. Bit flags are commonly used for permissions, feature flags, and low-level or performance-sensitive code. Question: how do you handle Boolean values that can be null when working with databases in Go? Answer: in Go, when a database column can be null, you should not use a plain bool because it cannot represent null. Instead, you can use sql.NullBool. It has two parts: bool for the value and valid to show whether the value is present or null. After scanning from the database, you check valid. If it is true, you can safely read the bool value. If it is false, the column was null. For columns that are never null, a normal bool is enough. Some database drivers also allow using a pointer to bool, where nil means null.
Question: how do Boolean values work in protocol buffers and gRPC, and how do you represent a nullable bool? In protocol buffers, a bool is a scalar type with a default value of false. In Proto 3, if a bool field is false, it is not serialized on the wire, which means you cannot tell the difference between false and not set. If you need to distinguish those two states, you should use a wrapper type like google.protobuf.bool value. This wrapper makes the field nullable so you can represent three states: not set, true, and false. This is useful for configuration flags, partial updates, and APIs where omission has a different meaning than false. Question: how does the Go compiler optimize Boolean expressions and Boolean to integer logic? Answer:
The Go compiler is very good at optimizing Boolean logic. Simple if statements are often turned into branch-free machine code when possible. For example, a function like ABS that checks whether a number is negative is commonly compiled into efficient instructions without extra overhead. When converting a bool to an int using an if statement that returns 1 for true and 0 for false, the compiler does not emit a branch. Instead, it generates a single instruction that 0 extends the Boolean value into an integer register. This means the code is fast, predictable, and avoids branch misprediction. The key takeaway is that clear, idiomatic Go code using Booleans is usually already optimal. You generally do not need to manually replace Boolean logic with bit tricks because the compiler already performs these low-level optimizations for you.